So here is the, excuse the annotations, here is the output from the Mount Grand processing that you've been seeing me work on. Before we get too excited about whether or not this is good, I mean, we can zoom in on it and see a nice clean looking ortho, and I'm sure the 3D is quite good as well. We should do some fundamental checks. So what we do is we go to a quality report. If it's a relatively small report, then Pix will create a PDF of the report, which is nice. If it's a very, very large project, unfortunately, it's only an XML report, which is not so easy to read. So if I just pop through this, and we will do a very quick check on the kinds of things that are important, and you'll see probably some errors on this report due to the type of work that it is. So we got lots of metrics that are not terribly important. Interestingly enough, here we can see that the data set is not happy with about 35 of the images. That will probably be as a result of those images not having any good key points because of low contrast. In this case, very, very large swaths of water on the model. Our camera optimization is well under 1%, which is good. And we did include some ground control points and leave some as checkpoints, although this project is probably statistically low on checkpoints because there wasn't a very high accuracy requirement from the client. So we did not use as many as we ought to have if we were really going to make an accuracy report based upon checkpoints. So let's just scroll down through this, and we'll have a quick look at what the report looks like. This is an interesting view, and this is the one showing the report with the manual tie point positions, and this also shows you the photographs that were badly calibrated and not used. And you can see how our calibration is actually pretty well nailed through most of this project, except for these areas here. These uncertainty ellipses are 1,000 times magnified. Honestly, this is a very good report, barring the fact that some of the photographs are not being used. We get some basic checks. I'm not so worried about the absolute camera positions because we're using PPK, so I expect them to be very good. What I do want to do is go down to the, this is a good example of a report that is working well, where we have high overlap and good key point capture. We're getting dark. Where we have insufficient overlap or bad key point detection, in this case over the water, or through the forested vegetation, we're getting bad key point created. So it's good to understand that if you did want really, really confident results in here, you would have to go back and refly at a different altitude or a different overlap or a different density. This isn't a bad report, it's just showing you where the bad parts of the model are through this data. And if we go to the ground control points, this is always one to check. This will tell you where the original ground control points were allowed to float a little bit, and it will tell you how much it floated them. In this instance, about 2.5 centimeters vertically, which is not a significant float. I certainly am happy with an RTK or a PPK process that's under 5 centimeters or even 7 centimeters at a push. It doesn't really matter as long as you know what your error is and you communicate it back to the client in metadata when you give them the survey. In this instance, we only had 2 checkpoints, but these 2 checkpoints are coming up as 4 and 6 centimeters vertically accurate, and that's quite a good result. Again, I would probably quote this survey as nominally, I would use my RMS error on my Z to say what my accuracy is. I always quote my Z because it's always less accurate than my plan data. Again, I probably skipped through some of these things, but those are the 2 important things for you to check when you're doing your assessment. And then we can go back. Actually, there's something else in here that I will show you. It's probably not in this report, but if you do have a problem with flying your job at multiple altitudes, somewhere in this quality check, you would get a statement saying that there is more than 1 block of model. It would say 2 blocks or maybe even 3 or 4 or 5 blocks. And those will be extra planes of data that are not orientating and connecting well together. And they are a sign that you've maybe changed your variation in your angle too much, or maybe you've flown at a very, very disparate altitude on one flight compared to another. It's not the end of the world. Sometimes you can go back and lift those out with Cloud Compare or some cleaning of your cloud. Sometimes they are